Thank you, honorable teacher, giving me the opportunity to say something about this presentation. Today's presentation topic is coin changing algorithm. This presentation presented by me, MD Saiful Islam, Institute of Information Technology, Noakhali Science and Technology University. This presentation presented to MD Wahidur Rahman, Assistant Professor, Institute of Information Technology, Noakhali Science and Technology. Now I am going to my first slide. Things to be explained it. There is some topic. First of all, dynamic programming and greedy algorithm. Second, definition of the coin changing. Third, example with the explanation. And fourth, time complexity. And fifth, difference between dynamic programming and greedy in coin changing problem. Now I am going to my next slide. Dynamic programming. What is dynamic programming? This is the valuable part of algorithmic program. Dynamic programming is a method for solving a complex problem by breaking it down into collection of similar subject problem just one and storing their solution. Dynamic programming is used to solve problem with the following characteristics, such as simple subproblems, second, optimal structure of the problem, and overlapping subproblem. Now I am going to my next slide. Greedy algorithm. What is greedy algorithm? A greedy algorithm always makes the choice that looks best the moment. It makes a locally optimal choice in the hope that the choice will lead to globally optimal solution. An algorithm is greedy if it builds a solution in say small step, choosing a decision at each step locally, not considering what happened ahead optimize some underlying criteria. Now I am going to my next slide. Coin changing problem. This is my presentation topic. Coin change is the problem, the finding the minimum number of ways of making change for a particular amount of taka using a giving unlimited amounts of coins. It is the general case of integer partition. Now I am going to my next slide. Here is the coin change problem solution using dynamic programming. Here is coin 1, 2, 3 and total amount is 4. Here is a problem. The size of the dynamic probe table is equal to number of coin plus 1 into sum plus 1. Second is the first column value is 1 because there is only one way to change if the total amount of 0. Now I am going to row part. Row, the total number of coins. The fact that the first index is 0 indicates that no coin is available. If the value index in the second row is 1, only the first coin is available. Similarly, if the value index is third row is 2, it means that the first coin 2 available add to the total amount and so on. The row index represents the index of the coin in the coins array, not the coin's value. And now I am going to column part. Total amount, because the first column index is 0, the sum value is 0. The second column index is 1, so the sum value coins should be 1. Similarly, the third column value is 2, so change of 2 required, and so on. As a result, each table field stores the solution to a subproblem. For example, dynamic probe table 2 and table 2 array and equal to 2 indicates the two ways to compute the sum of the three using first two coins 1 and 2. The final outcome will be calculated by values to column and row. So I am going to my next slide. Next slide is the Sudokus of this problem. Initialize a new array for dynamic probe of length n plus 1 where n is the number of different coin chains you want to find, and second one is because there is only one way to give change $0 set dynamic probe is 0 to 1. iterate through the array for the each coin, change the available and add the value of dynamic proc. Here is index minus coin array I to dynamic program array index for index ranging 1 to n. Dynamic proc n returns value. Now I am going to my next slide, complexity of change problem. Here is the problem overlapping subproblem. Here is the problem overlapping subproblem plus time complexity. So order of 2n is the time complexity, where is the number of coin. Times and space complexity will be reduced by the using dynamic programming to solve coin problem. Now I am going to my next slide. Here is the coin change problem solution, the greedy approach. So here is the coin is 5, 10, 20 and 25, and total amount, that means value, is 15. Here is the possible solution, and the best solution is 50. So minimum coin of the change problem of algorithm. First of all, get coin array and a value, and make sure the array is sorted, and take coin array as much we can. Increment the count and solution break it, otherwise the follow third step, and finally print the count. Here is the final amount of 15. So thank you honorable teacher, and thank you all.